Okay, a company produces bags of sugar whose masses can be modeled by a normal distribution. Okay, we have a normal distribution and we have a mean of 1,000, standard deviation of 3.5. Before I even read the question, guys, I am going to draw myself a normal distribution. Always draw this bell curve. If it's a normal distribution question, you should be drawing a bell curve. I can't think of many examples where you shouldn't, because even if you don't need it, it's so quick to do anyway. Just draw it very quickly. Quick bell curve. Okay, and put in mean 1,000 and standard deviation 3.5. So part A says find the well, hang on. A bag of sugar is rejected if its mass is less than 995 grams. Okay, so it's nice to think, where is 995 grams? Well, it's going to be over here. It's definitely going to be left of 1,000. If this is the standard deviation, it's probably over here somewhere. Now, this doesn't need to be exact, but it's like, so long as you're over to the left of 1,000, that's all that matters. Anyway, the probability, so the probability that, and you could say, you could call this x, just to help you write this, because this is the probability that x is less than 995 is equal to. Now this is easy, guys, because it's paper 2. You just sub in, where we do menu, probability, distributions, normal CDF, never PDF, and we go for the lower bound is minus infinity, which is this, which is already in the calculator, which is fine. Upper bound is 995. 995. The mean is 1,000, and the standard deviation is 3.5. Just always be careful, guys. Are they giving you the standard deviation or the variance? In this case, it's the standard deviation, so that's good. That's what you put in the calculator, the standard deviation. Press OK. And I get this, 0.076564, 0.076564. Is that what he said? 76564. Okay, good. If you want to write this as 0.0766 to 3 significant figures, that's obviously fine. But remember, guys, you get full marks for both. Okay, B, estimate the number of bags which will be rejected from a random sample of 100 bags. Okay, well, to find if the probability that one is rejected is 0.0766, we just need to do 100 times 0.0766, which is 7.6. Now be careful, guys. This is one of those questions where it says estimate the number of bags. They can't reject 7.6 bags. So we're going to approximate it to approx 8 bags will be rejected. That's the closest, that's to the nearest bag. 8 bags will be rejected. Will be rejected. Okay, and then finally part C. Given that, guys, that sounds to me like a conditional probability. So given that a bag is not rejected, so it is not rejected, find the probability that it has a mass greater than 1,005 grams, right? So I want the probability that X is bigger than 1,005, because that's what he says. Find the probability that it is bigger than 1,005. So the probability that is bigger than 1,005. Given that means I put that here. So given that X is bigger than 995, because remember, it is not rejected. If it is not rejected, then it will be bigger than 995. Remember, guys, because it's a normal distribution, it doesn't matter if you put greater or equal to or just greater than, because the probability that it equals 995 is 0. Okay. This is, now let me just write here, guys, so we're clear. The probability of A given B is the probability of A and B over the probability of B. So it's the probability of them both happening divided by the probability of the given. So this is equal to the probability that X is bigger than 1,005 and X is bigger than 995 divided by the given, which is the probability that x is bigger than 995. Now, common mistake here, guys, is to get this probability, and multiply them together. That is very wrong, and it's wrong because it's not this times this, it's this and this. You only multiply them if they're independent, and they're certainly not independent here. So let's think about this. What does it mean if something is bigger than 1005 and bigger than 995? Well, that's a bit silly when you think about it. If I told you, think of a number that's bigger than 3, and bigger than 6. How can I simplify? What kind of number is bigger than 3 and bigger than 6? Well, it's just, you can just say bigger than 6, because obviously if it's bigger than 6, it's bigger than 3. So I can actually, let me get rid of this. I can actually simplify that to be the probability. So this is actually the probability that x is bigger than 995. No, sorry, I did the wrong one. Bigger than 1005 divided by the probability that x is bigger than 995. Because, as I said, guys, bigger than 1005 and bigger than 995 is the same as bigger than 1005. Then this I'll do with my calculator. Menu, probability, distributions, normal CDF, bigger than 1005. Upper bound is just infinity. I'll just put 99999, 1000, 3.5, and I get 0.076564. And actually, guys, I knew that because 0.076564. Well, I should have known that because the probability that's less than 995 is going to be the exact same as the probability that it's greater than 1005, because it's symmetrical. That's 1000 minus 5, that's 1000 plus 5. Anyway, you don't even need to know that because it's in the you can do it in the calculator. And it's divided by, let's do it again, guys, even though you could calculate it pretty easily. Probability distributions, normal CDF, 995, 99999, 1000, 3.5, press enter, 0.923436, 0.923436, and this equals, just do this straightforwardly, 0.076564 divided by 0.923436, 0.08219 equals 0.08291, which is approximately equal to 0.0829223 significant figures.